When people first hear about electric vehicles, one of the first questions is often, are they as fun or capable to drive as a traditional car? For hybrids, the answer has always been a compromise. Hybrids rely partially on a gasoline engine, and while they can deliver some acceleration boosts, they are often heavier, mechanically complex, and slower to respond compared to fully electric cars. EVs, however, redefine what driving feels like, and in almost every aspect, they leave hybrids behind. Let's start with acceleration and torque. Electric motors deliver instant torque from 0 RPM, which means the moment you press the accelerator, an EV responds immediately. There's no turbo lag, no waiting for the engine to rev up, just immediate, smooth, and powerful acceleration. Many EVs can outperform hybrid counterparts in 0-100 km/h sprints, even with smaller motors, because hybrids are constrained by their gasoline engine's limits. In everyday driving, this translates to a more confident and enjoyable experience, whether merging onto highways or overtaking slower vehicles. EVs make city driving effortless, while hybrids often feel restrained when the engine engages. Handling and weight distribution also favor EVs. Batteries in EVs are usually mounted low and across the floor, creating a low center of gravity. This improves stability, reduces body roll, and gives EVs a balanced, planted feel in corners, something hybrids struggle to match. Hybrids have heavier gasoline engines at the front and complex dual drivetrains, making their weight distribution less optimal. The result? EVs are often smoother, more predictable, and even fun to push through tight curves, while hybrids are designed more for efficiency than performance. Another major advantage of EVs over hybrids is maintenance and reliability. Hybrids have both a gasoline engine and an electric motor, along with complex transmissions and energy management systems. More components mean more potential points of failure, more maintenance, and higher long-term ownership costs. EVs, by contrast, have fewer moving parts, no traditional engine, no oil changes, and fewer fluids to maintain. Regenerative braking reduces brake wear, tires last longer due to smoother torque delivery, and software updates can improve performance without touching the mechanical parts. This simplicity translates to lower running costs and less worry over time. EVs also shine in driving consistency and predictability. Hybrids constantly switch between engine and electric modes, sometimes creating inconsistent throttle responses or subtle jerks. This dual system can feel awkward, especially in stop-and-go traffic. When Ferrari decides to write a new chapter in supercar history, the world stops and watches. In 2026, Ferrari is set to launch its most electrified and powerful supercar, yet the new Ferrari 849 Testarossa, the rightful heir to the legendary Testarossa name and the successor to the groundbreaking SF90 Stradale. This isn't just another Ferrari, it's a fusion of heritage, innovation, and mind-bending performance that pushes the boundaries of what a modern supercar can be. Wikipedia. From the moment you lay eyes on it, the 849 Testarossa grabs your attention. Its design is bold and purposeful, a perfect blend of classic Ferrari cues and cutting-edge aerodynamic engineering. It's the low, wide stance, sculpted bodywork, and aggressive front-end signal that this is a car built for both road domination and track precision. The silhouette is unmistakably Ferrari, but there's a futuristic edge that hints at its hybrid heart. Wikipedia. Underneath the stunning exterior lies a hybrid powertrain that defines the future of performance. Ferrari engineers have paired a potent twin-turbocharged V8 engine with multiple electric motors, creating a system that delivers astonishing combined power well north of 1,000 horsepower. This means blistering acceleration, instantaneous torque from the electric motors, and breathtaking performance that only Ferrari can deliver. It's the perfect marriage of internal combustion, brutality, and electric precision. Wikipedia. But performance isn't just about raw numbers, it's about control, balance, and how a car feels when you're behind the wheel. Ferrari has refined the chassis, suspension, and aerodynamics to ensure the 849 Testarossa responds to driver inputs with razor-sharp precision. One of the most exciting aspects of this new generation supercar is how Ferrari is redefining hybrid performance without losing soul. The electric motors provide instant power and enhanced responsiveness at lower speeds, while the roaring V8 keeps the emotional feedback that Ferrari fans crave. This hybrid system doesn't mute the experience, it amplifies it. Wikipedia. Inside, the cockpit reflects Ferrari's commitment to blending luxury with performance. You're surrounded by premium materials, driver-focused controls, and cutting-edge technology that feels intuitive rather than distracting. Every element is designed to enhance the driving experience, putting you in complete control of one of the most advanced supercars ever made. In terms of real-world performance, the 849 Testarossa is jaw-dropping. Expect supercar-level acceleration that rockets from 0 to 100 km per hour in just a couple of seconds, and a top speed that challenges the limits of physics. But it's not only about straight-line speed. Ferrari's advanced aerodynamics and adaptive dynamic systems ensure gripping, cornering, and composure at every turn. When it comes to choosing a car, the initial price tag is always important, but the real cost of owning a vehicle stretches far beyond what you pay at the dealership. Over time, fuel costs, maintenance, taxes, and incentives can have a huge impact on your wallet. This is another area where EVs clearly outperform hybrid vehicles. While hybrids reduce fuel consumption compared to conventional gasoline cars, fully electric vehicles take efficiency and cost savings to a whole new level. Let's start with fuel costs, which are arguably the most visible ongoing expense for any car owner. Hybrids save money compared to traditional internal combustion engines because they use an electric motor at low speeds and during stop-and-go traffic. However, hybrids still rely heavily on gasoline. And when the engine kicks in, especially at higher speeds, fuel consumption increases. EVs, in contrast, operate entirely on electricity. Even if you use grid electricity rather than home solar, charging an EV is typically far cheaper per kilometer than fueling a hybrid with petrol or diesel. In many markets, driving an EV can save hundreds or even thousands of dollars a year compared to a hybrid, depending on your mileage. Next, consider maintenance costs, which are often surprisingly high for hybrids. A hybrid has both a gasoline engine and an electric drivetrain, plus complex systems like regenerative braking integration, dual transmissions, and cooling systems. More components mean more potential repairs over time. EVs, however, have fewer moving parts, no engine oil to change, and fewer mechanical systems that can fail. Brake wear is reduced thanks to regenerative braking, and software updates can improve performance or fix issues without ever visiting a workshop. Over a 10-year period, EV owners often spend significantly less on maintenance than hybrid owners,